Hello and welcome back. Today module we are going to talk about chi-square test. Plus I'm going to introduce to you graphics, basic graphics and more advanced graphics so you will be able to portray or display the result of your chi-square test in visualization. But let's try to understand what we will try to achieve in this module. You're going to learn how and when to use chi-square tests using what we call contingency tables and what it is and what the aim of it. And then I'm going to talk about how to apply R to chi-square and how to conduct that. And in Canvas, you will also find a layout how to do that. So what is contingency table? It is usually the ability to put in a table comparing multiple population or ability to classify based on two or more characteristics of the data. There are also the contingency table also are called cross classification table, and I'll show you example. Left-handed versus gender. The domained hand is left versus right. The gender is male versus female. So in this example, I'm going to display table that hold two categories for each variable. So it is 2 by 2. And suppose we have a sample of 300 children, and that's where we're going to see some idea how to sort it out in using table. So in this example, left-handed versus gender, and we will see that there is 220 females and 12 of them are left-handed, whereas 180 males and 24 are left-handed. And so this is a way for us to sort the data to make it more clear with regard to the classification of the data. Back to the test, the idea of the chi-square test. What we need to do is, first of all, we need to address the square test for the difference between the two proportions. So the idea here is that we have, back to our hypothesis, that one hypothesis will say they are equal, the alternative hypothesis will say they are not, and if they are different or if they are equal, that will be proven by using the hypothesis. So we are using x squared to find about that. The outline of the chi-square test is basically the idea of x square, and this is the statistics, and we are applying that the f0, the fe square, and we'll divide it by fe. So f0 is the observed frequency in a particular cell. Fe is the expected frequency in a particular cell if h0 is true, which means that the negative in our hypothesis it is true. So the idea here is that we are trying to measure it in a case that it is x squared for 2 by 2 case that has 1 degree of freedom. So this is where we are coming into rules and how to apply to them. So when we are making a decision with regard to our chi-square result, we are usually trying to reject or accept, not reject the result and based on our hypothesis. So if x2 is smaller than x2a, which means the reject, otherwise no rejection. And that's where decision rules apply. Computing the average proportion in this case is, again, I go back to the example that I started today. So 120 females, 12 are left-handed, 180 males, 24 are left-handed. So 24 plus 12 is equal 36 divided by the total of number of females and the total number of males, which will give us 0.12. So based on all 180 children proportion, it is left-handed is 0.12, which is basically 12%. So finding the expected frequencies, the idea here is that what we expect, and using the p hat in order for us to calculate that, is to expect the frequency for the left-handed males multiplied by the average proportion of the left-handed by the total number of males. So in this case, this is what we do. And how do we expect it? We multiply 0.12 multiplied by 120 number of total females in the sample, which will give us 14.4. In the male is 0.12 multiplied by the total number of male in this study, which will give us 21.6. So in this case, the observed versus expected frequency will display to us as the following: observed and expected, and how it been displayed. So the issue of the chi-square test statistics is the idea of taking this formula and breaking down the content of the formula. 12 minus 14.4 square root but divided by 14.4 plus 108 minus 105.6 square root divided by, and you get the point. So basically the chi-square test allowed us to come up with a result that allowed us to tell us what is the decision. Based on it, we can make a call with regard to the hypothesis. As I said before, is it true, or can we accept or reject it with regard to our hypothesis? And again, I lay out for you in this case if it is accepted or not. In this case, we do not reject. So the x-square test for the different among more than two proportions, and again it will allow us to do that, and not all. In that case, we are not allowed to. We are allowed to apply that and to justify it, and ability to observe and to reflect on it. And again, I broke down the chi-square test as the formula with the result of the table and be able to display that. So computing the overall proportion, I went over it's the p hat, and we are adding the x1 plus x2, etc., divided by the n1 plus n2 plus nc, and divided by n, and the same thing is expected with the decision rule with regard to how to accept or reject it. And again, we can do that c plus 1, the degree of freedom, in order for us to apply that. Okay, so now the cream of the class, and this is where the R is really a powerful tool for us to display that. So the R comes with a set of rich probability distribution function and a four consistent way of asserting them using R, D, Q, and P. So the idea here is that the R returns normally generate numbers, the D returns the highly probability density function, the Q returns the inverse density function, and the P returns the cumulate density function. So if you combine those with the name of the distribution, in the case of normal distribution, you will get get different types of distributions. For example, you can generate random numbers. You can find the value of the function of a specific point or produce critical value, and in addition to that, calculate the p-value. Most distribution, and I repeat, most distribution require one or more distribution to define the shape. So the F distribution is a right sig distribution, used mostly common to in various analysis of the variance. When referred to the F distribution, the numerator degree of freedom are always given first, and by doing that, you need to the degree of freedom for the monitor df1 and the denominator df2 to generate 50 random numbers, and you type the following: rf equal, you want 50 random numbers, the df1 is equal 15 and the df2 is equal 20 in order for us to do that. Let's look at an example in order for us to understand what has happened. So the study of the following information on the age of distribution library online user to report that 35% are between the age of 18 to 34 years old, and 51% are between the age of 35 to and 64 years old, and with 40% are 65 years old or older. Our revised data provide the following library habits. So the age of the library user and the frequency. Suppose now that the data resulted from a random sample of 200 Canadian library user. So based on those sample data, we can conclude that one or more of those three ages group. And how do we apply that? We are having the age, we having the frequency, and the table is age and frequency, and the syntax for the K-square test is square Q dot test and the table, and it will give us what we wanted with regard to the idea of the result. The x squared is equal 6, the df is equal 4, the ps value is 0.1991, and the r give us a warning. And he asks us that maybe the test or the table that we are use might not be the correct form. But this is part of what you need to be aware, and I want you to be conscious about that, because this is something that is the procedure. In your assignment or in Canvas, I display the idea of the square, and I gave you an example and how the R is looking at and what is the resolution in it and how to apply to it. So you will have a real example how to do that. I will just hold on a second. I will zoom in so you will be able to see it. And so again, I gave you an example and ability to see what it is entail in order for you to conduct this. So this is the chi-square idea and how to apply to it. But one of the things that we as in the R community like to apply is the graphic, in order for us to take advantage of what we found in this K-square test. And so when we coming to graphics, there are three options to the average user: basic graphics, lattice package, and ggplot2. I will go over the basic graphics. And the idea here is that it's plotting the area and then adding the elements. When you add the elements to the plot, you cannot remove them. So basically, it's a platform that you are displaying what it is exists, and in order for us to do that, plotting in R usually consists of four basic ways to do that. The P is the points of the default, the I is for the line, the B is for both, that points connected by line segments, the C stands for the connecting segment of B, and O is the overplot points and lines overplotting, H is for histogram, S for the stir, capital S is for alternative stirs, and N is for none. So basically what I can come up with is the idea of this type of visualization to show what is the distribution and how the data display in order for us to claim that our result actually is based on data. Points types. There are 25 different points, plotting points that can be used to define the argument. And basically, points 21 through 24 are multiple color points defined by the fill colors of those background color that can be stand for. So those are the issues that we can apply and can develop, and we can do that, or we can see that also with lines. Again, we have 1 to 6 type of different lines in order for us to show that. And we have also the width and the size, the width of the lines, the width of the points. And again, this is part of our terminology that we need to put into the code in order for us to make our visualization more transparent to everyone who sees that. Colors, in basic colors, we usually types colors, and he will lay out the 8 colors that basically is our standard in visualization. We can also use color palettes, which is the rainbow, the heat, or gray, and this is can be a powerful tool for us to display what we do. We can also use the alpha as a transparency and be able to apply the gray into value between 0 to 1, where 0 returns black, 1 returns white. So we have in between the gray in order for us to do that, and this is the way to the distribution of colors these are displayed. Plotting, building the plots, again, I'm using the cars and I'm using the plot. And again, I want you to see the terminology that I'm using in R in order for me to define it. Again, the plot, I ask the type is equal to 0 or O, and the color is blue, and I can give it a display of it. Run it and see what it is. But again, if you know me by now, you will say, is this good enough? And my answer will be probably not. Because it is like, it reminds me of Excel, and Excel for me in visualization is not good a platform. So we are trying to build in our community, we are trying to build additional visualization platforms or packages that will allow us to have more. One of the first graphic packages in R is called Letters, and it is the idea that can be customized but has no effect. So basically, it gives us the way how to display the data, but it doesn't give us more ability to manipulate the data or customize it, and the idea of how to take it. There is a lot of advantages to the Letters package, which is including multi-panel condition, converting additional information, or adding some obvious user data summary, and ability to have an argument with that. So how it will run? You need to install the package called Letters. You need to have the library, and in this case, the next line, third line, we are going to say X plot, and we are going to outline the arguments, in this case at lat versus long, and the data where it comes from, and the idea what it is, ability to plot it in a way that it is consistent, and that's the result of it and how to apply to it. So note that you can follow the commands to do the same thing and what it is and how to apply that. Why do we learn letters and why do I refer to it? They usually look better. They can extend the powerful ways. The result sometimes can be annotated, edited, and saved, and something that is really important. So the formula that we often use in letters package is the idea of we're looking at the letters function, and in this case give us a single vector. The formula is written as a single vector, and ability to apply to it and what is it remains out of it. So the histogram in this case is the histogram. I will put some data into it. I will define what is X lab and what is Y lab. I will give it a list, and this is the result of it and how it's been displayed. But last example is giving you a wireframe, and I don't know how many of you have attended my web development class. We are talking about wireframe all the time, but in R, when we are talking about wireframe, we are talking about three-dimensional. So in this case, I'm using wireframe and I'm using a volcano data set and shade in order for us to apply. So it gives us a three-dimensional respect with the data. And again, this is not my data, so I hope that you will not jump and take any data and try to convert it into this type of visualization, because it will not work. But again, the beauty of it, if you have geographical data, that might be a great way for you to convert the data or display the data. But I did not finish, and this is where I really am getting excited, because this is about ggplot2. And ggplot2, the creator of the package is called Handley Wickham. And Wickham is now the vice president of RStudio. And he is in almost my age, or he probably is younger than I am, but he is very active in developing the ggplot2 platform, and he allowed us to see what he has done. He has his own GitHub account, he has his own space that he communicate, and the idea of the structure of the ggplot2 is much more coherent or consistent and has a framework in order for us to do that. So the ggplot2 consists of the aesthetic, it consists of the geometrics, the statistical analysis, the scale, and other elements of the package provide coordinate system, the facing, the position adjustment, the data, the annotation, and the idea to multiply that into it. So what is the aesthetic? Plots all display some aesthetics. So some aesthetics are used in ggplot2. It provides us the ability to customize or give aesthetic to the X position, the Y position, the size of the element, the shape of the element, and the code of the element. The geometrics is the idea that we can shape the points, the lines, the line segments, the bar, and the text. And the scale is the idea of the controls of the mapping from the variable in the data to aesthetic. So in ggplot2, we often use color filtering scale to be determined automatically. But you can use your own custom color schema, so you can take more control over your map in the fill color using the geo points into it. So the geometrics has point shape, the point size, the line type, the line width, the bar, the fill colors, the outline colors, the text, and the label values. And in this example, this is what it will do for us. And again, the P is the entire container. The ggplot is the package that we are using. We are using, in this example, a data set is called empty cars, which is a set of cars, all cars. And we are trying to add more aesthetic to it by using aesthetic. WT is one of the variable, like the MPG is two variables in the empty cars, and be able to apply the geo points into it in order for it. Right now it's empty, but it provides more ability to do that. And in this case, I can add basically additional element in compared to generic graph in R that does not allow us to add anything. In this case, I can add a line and saying, okay, I would like to see the X interpretant equal 5 and what does it really means to my data set. So again, we are the ggplot2 help us to provide more interpretation to the user or to you as the analyzer, so you will have more concise way to present the data in order for you to apply it into it. So I talk about the code behind it and what is it entail. I highly recommend that you will go over to see what it in behind. As a reminder, next semester I'm going to offer the R, Introduction to R, so where you're going to build your own R package. So one of the things that we're going to see here is, in this example, is DF is the data frame, and I'm building a data frame. And again, how I build these graphics in order for me to apply and develop, again, this is the result of it and how to do that. So what makes the ggplot2 so unique? The idea that we are building the visualization layer by layer makes the ggplot2 one of the most powerful visualization tool that we have. And the data frame is part of how we collect or sort the data, so it will contain in one container and be able to assess it, and the ability to add aesthetic to visual help us to sort everything out and how to apply to it. And maps also, in my book I gave example of maps in reshape, and again this is the layout of the map and up to apply and how to address it. So I would like to summarize this class, and again I want you to go to see the issue of chi-square test in R, and I gave the breakdown in each component, and I also gave you how to apply the test in visualization, how to apply to it, and what is it really means in our case. The assignment in this case, I gave also a recommendation of reading. I highly recommend that you do, and because it will give you more background on the subject and the ability to do that. So I learned from your examples that you will give the same example again and again and again as if I gave it. So in this case, I'm going to give you a new example and you're going to do a new assignment. And so in this case, you're going to have a table, you're going to apply yes or no and total, and you're going to run the chi-square test in order for it to verify. I want to start to see your hypothesis statement in your blog. There is no place to do that in the visualization, so I want to see that in your blog. I hope it makes sense. I hope that the chi-square will make more sense. I hope you enjoy it. Until next time, have fun.